Alright, this is Anthony Cassione walking you through part 3 of the data analytics tutorial video series. Before we get started with anything else, we want to ensure that our version of Excel has the tools we're going to need. So we're going to come up here to File, down to Options, click on the Add-ins tab, select an Analysis Toolpack, hit Go right here, make sure it's checked, and hit OK. Now we have ensured that we have the tools necessary to run the analysis. Now that we know we have the statistical tools necessary, we can use this data set here, which we pulled a very similar one out of Access it into Excel. The first thing the assignment asks us to do is to run descriptive statistics. So in order to do that, we're going to come up here to the Data tab. We're going to go over to the right to Data Analysis. We're going to be using this a lot. The first analysis tool we want to select is Descriptive Statistics, as I said. Make sure your data is selected. Don't include any of this text. It may gum up your analysis. My data is grouped by columns, so that's fine. I do have labels in my first row. I want my output to be on a new worksheet down here rather than as part of this worksheet. And what we're asked to provide are summary statistics. Okay, here we have the output again on a separate worksheet. So we were asked by the assignment to provide the average, the median, and the histogram as part of step A. So here with this readout, we do have the mean or the average, and we have the median. In order to run the histogram, we're going to have to go back to the data analysis button. Alright, here we are back at our data set, and in order to run a histogram, you need to do the variables separately. I'm just going to show you how to do one. The process for the others is the same. You're going to come up here to data analysis once again. This time you're going to select histogram. It's already in because I had ran it through for heat complaints, so we'll do that. Again, I have labels. I want it on a new worksheet, and coming down here and selecting the chart output box is a good idea. It'll give you a better visual representation of the distribution of your data within your data's range. And again, here is the readout on a separate worksheet. Here's the visual representation, and here is it grouped together as it's represented here in a histogram. Next, we've been asked to create a pivot table using our data here. So what we're going to do is come up to Insert, select Pivot Table. The table range, just go ahead and select all your data, like so. I want it on a new worksheet, hit OK. And here we have the setup for a pivot table. Okay, now we can begin setting up the pivot table. You can do a lot with a pivot table, and what it's great to do is to compare across groups. So we're going to go ahead and start clicking these boxes just to give you a demonstration of what it can do. So just by clicking that there, we were able to separate our data by borough that easily. And you can play around with dragging these into different boxes down here to make different combinations, and again to splice your data up however you like. We've returned to our data set in order to run an ANOVA test. So in order to do so, we're going to come up to the Data tab. Once we've selected that, we'll come over to Data Analysis again, and there are options in here for ANOVA, but the easiest way to do it is actually just to click Regression and go from there. I'm going to delete these fields out, the input Y range and the input X range, to show you what to do. The Y range is your dependent variable. In my case, that's your natural gas consumption. That's what I'm trying to predict. And my input X range are my two independent variables, heat complaints and boiler complaints, in this case. I do have labels. My confidence level is 95%. I want it on a new worksheet, and everything else checks out. And here we have the results from our ANOVA test right here. And we're actually going to run this regression analysis again later to satisfy another step the assignment asks us to complete. We're back to our data set once again in order to run a correlation matrix, in order to develop one anyway. So once again, data tab, data analysis, select correlation. Okay. Our input range is our three variables: heat complaints, boiler complaints, and natural gas consumption. Doesn't matter which one is the X and the Y. They are grouped by columns and they do have labels. So we're going to go ahead and hit OK. An easy way to look at this and understand it is by, for instance, coming over here, heat complaints have a perfect correlation with heat complaints because they're the same. And you'll find that if you take, if you go down one here and over another, boiler complaints match up with boiler complaints 1-to-1, and these other numbers are the correlation between the variables. Heat complaints and boiling complaints have a correlation of 0.72. Now that we've finished the correlation matrix, another way to look at or to examine correlation in a more visual representation is by plotting a scatter plot, and we're going to do just that. In order to demonstrate how to run a scatter plot, we're going to use the variables heat complaints and boiler complaints because, as we saw from the correlation matrix, they are somewhat correlated and will hopefully give us a nice shape to our scatter plot. So in order to do that, first we're going to select both of these columns, excuse me. Come over here to recommended chart, and scatter will usually be the first one, as Excel knows that's the chart to be used. And then just click OK. You can play around with naming the axes. You can add additional data labels, a trend line, and you can go into the trend line options and actually have it display an equation for you as well. In order to provide a regression, which is the last step in part 3 of the assignment, Professor Yim asked for, you do the same thing we did to run an ANOVA. Here we have, this is an identical readout, except the regression is concentrated on these numbers here, specifically the coefficients. The way you come to this output is the same exact as the steps we took to find the ANOVA, though. Thanks for watching.